Good morning. So I'd like you to go to page 133 and do the lesson by yourself using this video, okay? So let us start with the first task. A group of college students developed a solar-powered car and entered it in a race. The car travels at a constant speed of 100 meters per 4 seconds. And question A tells you or asks you, what representation can show the distance the car will travel over time? Okay, when you read the question, what representation, I would like you to turn some pages back to page 124, okay, and have a look at this key concept. Here it shows you that what can be the representation. The information can be represented by table, okay, and from here you can find the constant of proportionality. It can be represented by graph, and from graph also when you are dividing y by x, you also get your constant of proportionality, okay, and also the information can be represented by equation. And remember, in the equation, this number was a constant of proportionality. So actually here, in this question, we are writing the answer that representation can show. Which representation? Table, graph, and equation. Okay, so for example, if you write the table, you will see that 100 meters per 4 seconds, you can easily find the constant, it's 25. Or you may draw a graph and do the same. Now question B, what expression can show the distance the car will travel over time? And expression, you already could see that the constant is 25, so the expression is y equals 25 by x. Now, when we compare, for example, that table that we had and this expression, the question is compare the representation and the expression which shows the distance traveled over time more clearly. Again, the table, this table shows, okay, maybe more clearly. To my mind, it's more clearly. But what about this equation? The equation helps us to calculate any distance, okay? You just put here time and you get any distance. You put here any time, you get any distance. The distance because this is like 25 meters per second, so okay, how long is going to be the distance after 8 seconds, for example? So you multiply 25 by 8. After 12 seconds, you multiply 25 by 12. And this how expression helps you to find the distance after any amount of time. Okay, it was kind of introduction Now you turn the page to 134. Okay, go to page 134. Let us discuss very quickly the examples. Okay, at the very top of the page, it's not here, but at the very top of the page above this example, you can see the question: how does slope relate to the equation for a proportional relationship? Here I want you to write that slope is the same as constant of proportionality. Right now, grade 7, they are learning about constant of proportionality, and they are writing that equation, that y equals k to x. This k is constant of proportionality. Where do we get that constant from? You are dividing y by x, either in the table or in the graph. Doesn't matter. You just need to clearly know which number is x and which number is y, and divide number that represents y by number that represents x. That's how you find that k. Today we are going to talk and to learn about the same thing, but instead of constant of proportionality, there is going to be that slope. And you remember from the last lesson, what is slope? It's rise over run. What is rise? It's y. What is run? It's x. So actually that's why it's the same, but only in the equation like this, we are going to use another letter. Okay? Constant of proportionality, this is letter K. Slope is going to be, I will tell you a little bit later, is going to be letter M. That's it, okay? But actually M and K, this is the same. So that's why I can say that nothing new. Nothing new. Okay, example number 1. Someone is building a fence. This is the length of the fence, and this is the price paid. And the question is, what is the relationship between the length and fencing of the fencing and the cost? Of course, you here you may use that formula. You divide y cost by x, the length, and you when you divide, you can get, for example, that 30 divided by 6 is going to be 5. Yes, from this information, when you divide, you can see that this is 5. 5 is going to be a constant of proportionality. Now, when we move to step 1, okay, here that example tells you that you put all the numbers from previous picture: 6 and 30, 15 and 75, 24 and 120, those lengths and dollars. Here these numbers mean dollars, okay? You put them in ordered pairs. What does it mean, ordered pair? X, Y, X, Y, X, Y. Why? Because length is X, cost, dollars, is Y, okay? You put these numbers, and again, last lesson we were calculating how much is the rise, how much is the run, okay? Let us do this. For example, here, again, slope is rise over run. What is rise here? You can see that rise from, okay, let's say from 15. Okay, let's say from 15 till 24. Let's say from here to here, from 15 till 24. You see that it's okay, wait. From 15 till 24, it's point X. This is x2, this is x1, so this is going to be 9. Run is going to be 9. Okay, and rise from 75 till 120. It's going to be 45. When you divide 45 by 9, you get the same 5. You get the same 5, you see it. Okay, so here let's say too much writing, okay, but we get the same result. And I told you last time that way number 2, not using y2, y1, x2, x1, and use that formula. Okay, you may use that formula, but you may not use that formula. You may do what? Just take any y, divide by any x. For example, take this. You take y75, divide by x15, and you get the same 5, okay? The same 5. So, here just different ways are shown to you, yes? But if you remember that formula, that constant, and now you know that constant is the same as slope equals to y divided by x, so it's easy for you to understand. Okay, so step number 2. So we did the step number 1. Here we identified everything. Let us go to step number 2. Okay, step number 2. In your books, you can see step number 2. Analyze those triangles, okay? So we analyzed, we find out that the slope is 5. Okay, so this is easy. Let's move to another. Okay, from here, that 5 that you found, that 5 that is constant, this 5 is also a slope, okay? So, but that slope is going to be letter m. And equation is going to be y equals m by x. For this line, m equals 5. So, one more time, what is m? It's a slope. What is k from grade 7, from that formula? It's constant of proportionality. If slope the same like constant, that means that m is the same like k. That means that that equation with slope, it's the same like that equation with constant. Okay, is it clear? I will ask you next lesson. Okay, now let's go to try it. Try it. This is try it, page 134. Write an equation to describe the relation shown in the graph. What can we see in the graph? We can see here the dot. Here we have y is 80. 80. And x is 4. Okay? You may circle it for yourself. So 80 over 4. 80 over 4, yes, because y over x, and you see the x is 4 together with 80, minus 3, put here 3, and you go up, and you see that the dot is going to be here, and here you see that y is going to be 60, so 60, y2, this is y1, no, this is y2 and this is y1, sorry, okay. minus 3. Okay, when you do minus, you will see that 80 minus 60 is going to be 20 over 1. So the equation for this line is going to be like this. Okay, and this is the same as that I was telling you. How do the equations, this and this, how to compare them? You know that they are equivalent. And it's the same like K. Okay, next, let us go to example number 2. Okay, from this generalized topic, okay, or rule, I want you to remember this. If you have the coordinates, if you can see like this, so y and x, all the lines that go this way, to say slant, here it tells you that they slant, upward this way, okay, from left to the right, they are called positive slopes. Lines that slant downwards from left to right, again from left to right, they are called negative slopes. Just remember visually which line goes positive slope, which line goes negative slope, okay? So, here we have an example about drone, and the drone descends, that means goes down, okay, into a mining cave. The graph relates its distance below ground to time. This is distance, this is time. Write an equation that describes the relationship. Okay, let us move to another page to show this. So, first of all, we need to find the slope of the line. Okay, from point to point, it descends, okay? So, okay, let us find, for example, here, yes. It was minus 50 and 2, so you may draw a dot here by yourself to see that it was here and stopped here. Okay. So this is, we have point A, and this is, we have point B. So let us write by ourselves what we see. Point A, x is 2, y is minus 500. Point B, x is 3, y is minus 750, okay, like this. This is, you have 2 points with their coordinates. Now, to find the slope, you know that formula, I hope that you know it, that you take y2, it's minus 750, minus 1a, it's minus 500. x2 you have 3, x1 you have 2, so you write 3 minus 2. Here again, I remind you, if you have minus, it becomes plus. That's why minus 750 plus 500 is going to be minus 250 over 1. So the slope is minus 250. That means that the drone descends or goes down 250 meters per second. per second. This is we interpretation. This is how we interpreted. Interpreted, sorry, this is R, okay? Interpreted the slope. Okay, so and equation is going to be like y equals m by x, but that m you already found, m is minus 250. So y is going to be minus 250. Sorry, this is x, okay? This is the equation. Okay, now okay, now this is example number 3. Okay, a recipe for trial mix calls for 1 cup of raisins for every 2 cups of granola. Write the equations that describe the relationship between the raisins and granola, then graph the line. Okay, actually, what do we have here? We have here the graph. Already you can see it in the book. Okay, cups of granola are going to be x. Okay, x. So x is going to be 2. Y is going to be 1. Because raisins goes 1, okay? Again, you look at the graph and you see that raisins are here. That means that y is 1. Granola is here. That means that x is 2, okay? Now we are writing the equation y over x. So y over x is going to be 1 over 2. So this is our m. Now you put this m here, and you see that y equals 1 over 2x. Okay? That's it. That's it. Then later on the graph we can put our dots. Okay? Now let us try it. Okay? We need to draw, actually, to graph the lines. So write the equation of a line, number 1. So what can you see on this picture? You can see that x, okay, where, first of all, we are looking where our lines are crossed, and okay, put a dot here. Okay, you can put a dot here also, but here you don't have numbers, okay? You need to guess the numbers. But here you can clearly see the numbers, and you can clearly see that x equals x equals 10, yes, and y equals 4. So formula is y over x, that means 4 over 10. Then you simplify it, and you have 2 over 5. You simplify, you divide by 2 to get the smaller number. So that means that equation is, because you're supposed to write an equation, So the equation is y equals 2 over 5 x. Okay? This is the equation. Okay. Part B. Graph the line y equals minus cx. To graph any line, we need to have at least 3 points. Okay. To have those, let me draw a table for x and for y. Okay, if I take x0, I substitute into the formula, and I see that y equals minus 3 multiplied by 0 is going to be 0. If I take x1, it's going to be minus 3 multiplied by 1, minus 3. Okay, and if I take x minus 1, for example, it doesn't matter, you may take any numbers, I'm just giving you the examples. So y is going to be minus 3 multiplied minus 1 is going to be just 3. I need to put 3 points on the graph and make a straight line. Okay, 0 I put here. Then I calculate 1 minus 3. So I have here 1 and I go down 1, 2, 3, minus 3. So this is one of my dots, okay? Then minus 1, so go minus 1 here and 1, 2, 3, go here up because 1 is 3. Okay, here you have 1, 2, 3 dots. Just take a ruler. I try to take a ruler because both of my hands are busy. Draw a line like this, okay? It means you grab the equation, okay? This is what you were doing. You were graphing the line y equals minus 3x, okay? Okay. Now, let's go to our page 136. Page 136. From this page, at the very top, you can see key concept. This is the rules that you need to remember. Okay? This is the rules that you need to remember. From here, you need to remember the equation for proportional relationship is going to be like this. Y equals m multiplied by x. And what is m? M is the slope of the line. That's it, okay? And now, let's go. Question number 1. Let's go to our tasks. Do you understand? How do you know? All the rest. Okay. Question number 1. How does slope relate to the equation for a proportional relationship? Okay. So here we are writing. The slope is the same as constant of proportionality. Y equals m multiplied by x. This is about slope. Y equals kx. This is about constant. But this is the same, okay? Next, look for relationship. What do the graphs of lines in the form y equal to mx in common? How might they differ? Graphs. Right now the question is about graphs. What do they have in common? First of all, they all those graphs pass through the origin. Origin is 0, 0. Remember this, okay? What is different? That they might have or may have slopes. Okay, those lines in the graph, they may go different direction, up, down, to the right, to the left, and they can be steep or not very steep. So they may have slopes of different steepness. If you have a question about this in the class, you may ask me. And direction. Direction, where to go, to the right or to the left. Okay, so this is your writing here. You know that those questions 1, 2, and 3, they are about writing a lot, okay? Number 3. The table below shows the distance a train traveled over time. How can you determine the equation that represents this relationship, okay? So, what do we do? First of all, I can find the ratio, okay? Ratio, again, you are dividing the ratio. Distance over time. Distance over time. So you divide distance over time. And write, okay, 25 divided by 2 is going to be 12.5. 50 over 4, 12.5. 75 over 6, 12.5. 100 over 8, 12.5. So, you found that constant of proportionality, okay? This is K. But this is also the slope, so this is M, okay? So, what is the equation? What is the equation going to be? Y, M, X. Instead of those M, you put that number. So the equation is going to be Y, 12.5 by X. Okay? Understand with this? Let's move on. Okay, question number 4. The relationship between a hiker's elevation, you see it's Y, elevation is here, and time is shown in the graph. Find the constant of proportionality of the line, then find the slope of the line, then write the equation of the line. Again, we do the same. Look at the line. Where the line crosses the that grid, okay? Nicely. Where it crosses. You can see the dot here. You can see the dot here. You can see the dot here. Look. Okay? Now draw a lines like this to see what are the numbers. Draw like this. So, right now, what can you see? Even from the first one, take Y and divide by X. Y is 30. Y is 30. You divide by X1, you get 30, yes? So ZK is 30, constant of proportionality. That means that M is also 30 because this is the same. This is the same. The equation is Y 30 by X. That's it. Okay. Next, graph equation. Here you need to draw. Okay, equation we have minus 1 over 2x. That minus 1 over 2. Yeah, it's like 0.5, yes? 1 over 2 is 0.5. Okay, so again, as I told you already, you need to find at least 3 points, okay? At least 3. So, again, you need to draw a table about x and y. So if x is 0, y is also 0, it's the beginning of this, and you put the dot on the 0, okay? Next, okay, let us take let us take point 2. X is going to be 2, so y is going to be minus 0.5 multiplied by 2, and it's going to be 1. Minus 1, okay? And if you take minus here, it's going to be 1 here. So let us draw 2 and minus 1 here, 2 like x, minus 1 here, and minus 2, 1, 2, minus 2, and 1 here. These are our dots. So take a ruler and make a straight line across this. Okay, make a nice line, not like me. Use your ruler. That's it. We did our job. We graphed the equation like this. 3 dots is enough. Again, I'm telling you, try to make one dot, try to make one x positive, one x negative. then you will have the line that comes, that goes over the whole coordinates plane, okay? Next, let's go to number 6. Heart rate is a measure of how fast the heart beats when a person is not performing physical activity. The graph shows the number of heartbeats over time for a given person. Use 2 sets of coordinates to write the equation. Okay, let us use 2 sets. So in the graph you can see that the dot of crossing 280 crosses with number 4. Okay, can you see this? Okay, we have also here. We can have also here, but let us put those numbers in this equation. So 280 over 4, because over x is 4, okay? Then you have x2. What is y? What is y? Look up. Look up. The y is 140. So you're writing here 140. So it's going to be 140 over 2 is going to be 70, because when you divide you get 70. So one more time, where are these numbers from? 280 is from here, 140 is from here. Now about x's, 2 from here, sorry, 4 from here, 4 from here, and 2 from here. When you do your minus, you have 140 over 2 is going to be 70. Now interpret this equation in words. The heart's resting heart rate is 70 beats each minute. This is how we interpret. Okay, now let's go to number 7. The graph relates the number of gallons of white paint to the number of gallons of red paint, just used to make the perfect pink color. Write the equation that describes this relationship. Again, in this graph, find the dot on the crossings, okay? And this dot is here. Only here, it's very clearly, okay? So circle the numbers, what you see. And you see that y equals 1, x equals 4. So the equation is y over x is going to be 1 over 4. This is our slope. This is our slope. So the equation is y is going to be 1 over 4x. That's it. That's it. Okay. Franco made this graph to show the equation y equals minus x. Is the graph correct? Explain. Okay. So let us discuss what does it mean minus x. That means that if x is 1, so y is going to be minus 1, because the formula is minus 1 multiplied by x, okay? Again, if here you can see nothing, that means that here is supposed to be 1. Actually, let me write here. Actually, minus x, that means minus 1 multiplied by x, okay? This is supposed to be here. You need to know this. So that's why, again, y is 1, y equals minus 1 multiplied by 1, and it's going to be minus 1, okay? So that means that here on this graph, there should be point 1 and -1. So the line should go this way, okay? So that means that the graph is not correct. Okay? So you may write that not correct, because it should pass the point 1 minus 1. Okay? Again, if about this any question, ask me in the class if you still have any questions about this. Let us go to number 9. The graph shows a proportional relationship between the variables x and y. Write an equation to model the relationship. Okay, let us look at the dots where everything is crossed. Here, 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 here. Okay, now choose number. You see, choose number. You see here and here. You see 24 and 2. Y and x. So the formula is y by x is going to be 24 by 2. Is going to be 24 by 2 is going to be 12. So that m equals 12, okay? And the equation is going to be y equals 12 by x. This is the equation. Okay, and the question is, explain how you know if an equation graph represents a proportional relationship. Okay, rule number 1, that the graph it is represented by equation in the form y equals mx. Okay, write this. This is condition number 1. If the graph represented, or we can represent the graph in the formula, by the formula like this, that means that this is proportional. And condition number 2, it passes through 0, 0. This is condition number 2 for proportionality. If the line passes through 0, 0, it's proportional, okay? Okay, now let's go to number 10. Number 10 and number 11, it's again about graphing. So do you remember how many dots do we need for graphing? We need at least 3 points. Okay, and again we need to make a table to find out about x and about y. So x, y, 0, 0, 1, minus 1. If x is 1, y is minus 5 by 1 is going to be minus 5. If x is minus 1, you multiply minus 5 by minus 1, it's going to be 5. Okay, now let us put those dots. Okay, so we have 1 and minus 5. So 1 is here, 1 is going to be here, minus 5 is going to be somewhere here. Let's say this. Somewhere here. Okay, so minus 1 we go here and it's going somewhere here, you see? Okay, and the line is going to go like this. Okay. You use your rule, your line is going to be nicer than mine. But you see this line is very steep. Okay?